Concurrency in Go is super powerful, and it's very easy to create a concurrent program via Go routines. But the issue arises when you don't manage shared data effectively. You might run into issues like data races, data corruption, and even system crashes. Go provides us with a way to deal with it via channels and mutexes. In this video, we'll be looking over channels and mutexes, and also we'll talk about select statement. We'll start by looking at a data race situation. We will be solving it using mutexes and channels. If you're new here, let me introduce myself. I am Rahul Bharti. I am a senior software engineer at EPAM Systems with over 6 years of experience in building softwares. Let's get started. Alright, let's start by exploring channels first. So, in GoLang, channels are a typed communication pipeline that allows us to send and receive values between multiple Go routines synchronously. To create a channel, we have a chan keyword available, and we have buffered channels, unbuffered channels, as well as directional channels in GoLang. So let's start by creating a channel first. To create a channel, we need to use make function, and in that we need to provide it with the chan and the type of it. Let's do it a string type. So this is a unbuffered channel. In unbuffered channel, the channel is blocked until the Go routine receives the data. So let's start by sending some data from a Go routine. So let's do go func, and then we just run it right away, and in that we'll just pass in data. So we to pass in data we use variable followed by the arrow key and then the value, and this is enough. And now we are sending an hello to this particular channel. Here we can just get data from channel using again an arrow, but this time arrow will be before the channel variable itself. Let's save and let's run this. Go run main.go, and we get hello. Let's start by adding one more value to it, and let's do it hello world, and we can do channel one more time, and let's take it run main.go. We get hello world. Now here's the one thing that right now we are sending this data from a Go routine, and it's an unbuffered channel. As soon as you are receiving this value, it will always have more data to it. But we can also define the amount of data or amount of values it can process at a time. So we can do that using buffered channel, where we can define the size of it. We can just give it as a 3, and we'll just change some things, like we'll not do that, but let's just add here like hello. Then again we'll pass more data to it, world, and more to it, and last would be the hello. Let's start by running this ch, and let's see what we get. We get hello world and exclamation mark. This is an buffered channel. Here there are no receivers as such. There is no other Go routine that will receive this value, but it will still take up to 3. Now if I try to add one more here, let's say if I add in like crash. Let's do this a crash, because here our program will start crashing. Let's save and go, and yes, we get an error saying that chan send, and we don't have any Go routine that will be taking this value, and our buffer is full, so we are in a deadlock situation. And this is what we specify as a buffered channel. Here sending multiple values, we can send multiple values without blocking it, but up to a fixed capacity. Now we also have like a directional channel. So directional channels are limited to, like, they can either send or receive it. So let's start by updating this function. Let's start by creating a function that will just send data, and here we will have channel and chan with pass into as a string. This will only send value to the chan, which will be of type string. So we can do the chan, and we can do hello world. And then we have and receive only channel. So we can have func and receive chan, or we can not chan, let's do it receive data. And in this we can have ch we are receiving data into the channel, and here it will be of type chan with string. Just take a moment and look at the declaration or the argument type, how it's been defined here for a receiver and a sender. For a sender we have a type, and we have a channel type first, and in receiver we have the type and the arrow before the chan keyword itself. So let's do fmt dot println, and here we'll just print the value chan ch, and here we will create a channel of type string. Let's create it as a unbuffered type, and let's create a go routine for send data, so we can send data through the go routine and receive data which would be not in a go routine, and that should be fine. Let's add a ch as well, and this should be good to go, and we get hello world. So we just saw buffered channel, unbuffered channel, as well as we saw directional channel, where the particular functions are limited to only sending or receiving it. But here we are only listening to one channel, and we are providing some work on that. What if I want to listen to multiple channels? What if I want to make sure that if data is received to the channel A, we need to do something? So for that we have a select statement with channels. So I'll just paste that code. It's very long, so I'm not gonna write that, but here it's a very simple function. We have two channel, both are unbuffered, and then we have a function go routine 1, where we are just simulating some some operation and sending channel from channel 1. We do the same thing for the another function, and the select is basically like a switch statement, but we are using select. With this we have the case, and for message 1, with if we get it from channel 1 first, we'll print this out. If we are getting it from channel 2, we'll print this message 2. And then we have a case in which is a default case, that is after this particular time period, please just say it's timeout, and we don't have received any response yet. Let's start by running this program now. Go run main.go. So we should be receiving from channel 2 first, and then I think that's the only operation we should be receiving. Let's take a look at it, and we get from channel 2, as it only takes 1 second to execute. So what if I remove this? I don't have anything else. So if I do that, so we get from channel 1. These are really good if you are running a multiple go routines, and you want to make sure that depending upon the value I want to run this particular function first, or only this function, at that time you can use a select statement. And now we'll take a look at the data race condition, and we'll see how we can fix it using channels, and then we'll talk about mutexes. Let's get started by looking at this Go code. Here we have a counter variable, which is a shared variable, and it's gonna be shared around between different Go routines. So in the main function, we are creating a Go routine for an increment function, which updates this counter. Let's start by running this program, and the expected output should be 5000, but let's just take a look at this once. So we got 4000. Let me do it once more. We got 2000. Why this inconsistency? It's because the counter plus plus is not just an atomic operation. Here we are not just accessing but also modifying a data, and with the different Go routines trying to access it at the same time, we are creating a data race condition. To fix this, we can use channels and mutexes, but let's get started by fixing it via channels. Let's start by first declaring our channel. To declare a channel, we need to use our make statement, and in make we will provide it with the chan and the type of the channel, and that should do it. And let's also update this increment function to be something to having its own channel. So we can do ch chan of type int, and the for loop we can update it to being have maybe a value like a delta equals to in range of chan. And here, rather than doing counter plus plus, we can do counter plus equal to delta. And now let's add our go increment with channel, and here we can just pass in value as 1, and this should be good, but let's also close the channel so that we don't keep any channel open that might lead to memory leaks and other issues. And let me just quickly run this, go run main.go, and we get final counter as 5. Let's do it once more, 5, one more. So this is the one of the way to have its own go routine with the channel to make sure that we are synchronizing our data without losing or without creating a race condition. And now let's take a look at using mutexes. So let's start by creating our first mutex variable. So we just do var mu, and then we just go with sync dot mutex, or also known as mutual exclusion. It's a primitive available in GoLang that defines or locks a certain um, part of the code until it's done. So we can do mu dot lock, and then we can do mu dot unlock. And let's try just running this, and let's see. Go run main.go. We get, it's still right, there's still a difference. The reason is that because when we are running this again with a lock and unlock, it's still in a multiple go routines. We also need to make sure that these go routines are running on their own, and they have to wait until the go routines are done running. So to do that, we can do, let's start by adding wait group to the increment. So we just do sync dot wait group, and here we just defer the wg dot done, and I think that should be enough. But here we also need to we need to create a wait group so that can be passed to the increment function. To do, we can do wg, and it should be of type sync dot wait group, and here let's just pass the pointer to it, and also let's increment our wait group by 1, and at the end of it let's just wait until it's done. And let's save, and let's run it once again. Okay, I'm getting some error. What is this? Negative wait group counter, and why is it that I'm getting negative wait group counter? mu.lock, mu this, increment sync dot wait group dot add 1. Oh, it's not done, it should be wait, sorry, my mistake. Let's run it once again, and we get 5000. Let's do it one more time, it's 5000. So we can use mutexes to lock a certain part of a code that can be accessed by the different different go routines in and await them with their wait groups. So we started by looking at the channels, then we move on to the looking at the data race condition. We solved it using channels and mutexes, and then we also even looked at the type of the channels with select statement. Now you can use channel for communication between your multiple go routines if you are building a concurrent system, and you know how to use mutexes to protect shared memory or shared space. You know when to use buffered, and how to decouple the sender and receiver, and how to use a select statement. And I'm really happy that you watched this video, and if it has been really helpful to you, definitely let me know in the comments, and happy coding.